Hi, my name is Ed Aviza, and I'm a senior solution architect at Outsystems, the industry leader in high-performance, low-code application development. Today, I'm going to present an overview of event-driven architecture in Outsystems Developer Cloud, or ODC, our fully cloud-native visual application development platform. Event-driven architecture can enhance your applications by enabling loosely coupled communications and interactions within and between your applications. So what is an event? In short, an event is something that happens or takes place. In your applications, events can be triggered by human or machine activities, and these events can be consumed by other applications or even the same application that triggers the event. From the perspective of ODC, an event is triggered by a producer app and consumed by a subscriber app. Events are passed to a message broker that acts as the middleman or orchestrator between producer apps and consumer apps. An application can be both a producer and a subscriber, so you can design systems that use event-driven communications to pass information between actions in a single app or between multiple applications. When an event is published to the message broker, an application that has subscribed to that event will receive an asynchronous communication of its data payload, which it can then use to complete the appropriate actions as required. Let's drill down on these concepts a little bit more. Here you can see the flow of a single message that is triggered by an event in application 1. As you can see in the image, an event can only be triggered by the application in which it has been defined, but that message can be consumed within the same application as well as within other applications that have subscribed to consumed the event. By defining this type of event message flow within a single application, you can create an asynchronous event execution thread that provides loosely coupled communications within the application, providing developers with flexibility in their designs. The event-driven architecture in ODC relies on the publish-subscribe approach to passing information between actions within the application or between the producer application and a subscriber or consumer application. Notice that a single event type can be consumed by multiple applications, and subscriber applications can consume multiple events and event types from multiple application sources. So what are the benefits of building applications using an event-driven approach? First of all, using events to communicate information asynchronously promotes building applications in which consumers and producers are loosely coupled. This provides a great deal of flexibility to developers because loosely coupled applications can significantly reduce technical debt by allowing applications to be more easily modified than would be possible in traditional tightly coupled applications. In addition, because there are no point-to-point integrations between applications and components, it's easy to add new functionality to applications because they can simply subscribe to event streams as necessary. Event consumers respond immediately to events as they are received, so not only is asynchronous communication assured, but parallel processing scenarios become much simpler to build. Finally, event-driven architectures allow the creation of highly scalable applications and distributed systems that can utilize advanced approaches such as parallel batch processing capabilities. Now let's look under the covers to see the internals of how events work in ODC. In an event, the maximum payload is 10 kilobytes, and event payloads can only consist of primitive types such as text, numbers, Boolean values, dates, etc. More complex data types such as structures, lists, or records cannot be sent as event messages. Each event type has its own queue, which promotes isolation of events, and the maximum queue size for any given event type is 10,000 events. Events are delivered exactly once to consumers, but delivery order is not guaranteed, so be careful not to structure your applications to assume that an event will be received in an ordered fashion. If an event fails to be delivered, the system will attempt a total of 10 retries, and the interval between retries is determined by the backoff policy. Finally, each producer application is allocated a maximum of 100 threads for event execution, with a 2-minute maximum duration for each execution thread. This points to the need for exception handling to ensure that events have been successfully triggered and their payloads consumed by their consumers. To handle exceptions within a producer application, developers should create exception handlers within the actions that trigger events. Some examples of possible exceptions that may occur include attempting to send a payload larger than the 10K maximum, overloading the event queue with more than 10,000 events, and delivery failure to one or more subscriber applications. Outsystems makes it very easy to manage exception handling, and appropriately managing exceptions is critical to building scalable and reusable applications. Similarly, exceptions may occur in consumer applications, and these should be handled as well and for the same reasons. An example of an exception occurring in a consumer application is the possibility of an exception timeout occurring before the event is completely processed by the consumer. Make sure to build robust exception handling into your apps to ensure that your systems work as expected. Now let's take a look at the differences between synchronous and asynchronous processing, as well as how parallel processing pattern can be built using ODC. With synchronous processing, a request by one application can be sent to a second application for processing. However, the thread from the first application remains blocked until the second application returns a response. This means that the first application must wait until the response is sent by the second application and received by the first. This can cause applications to become sluggish or even hang if an error causes the return result to fail. In an asynchronous processing scenario, the first application can send as many requests as it requires, and the second application responds by processing each request as it is received. The producer application in an asynchronous processing scenario is not blocked while waiting for responses from the consumer because the event queue can handle up to 10,000 events. By using events within a single application, developers can create apps that use asynchronous processing internally to create more flexible data flows and improve application performance. Triggering and consuming events within an application generates a new execution thread within the application that can handle processing without blocking the triggering action to wait for a response. By using this approach, developers can easily build asynchronous parallel processing functionality that can process large amounts of data without blocking the triggering actions within that application. Up to 100 event execution threads can be launched per application, and additional triggered events beyond the first 100 can be queued up to the 10,000 event maximum per queue. Events will be retried in the event of failure as per the retry policy discussed earlier. For even greater scalability, a parallel batch processing approach can be built that can manage a high volume of parallel processing across multiple applications. Let's take a look at how this works. Outsystems supports many constructs that make developing applications easier and faster than when using traditional code. By using the timer construct in your application, you can set an interval that can trigger a flow that processes a large number of records by adding them to smaller buckets or batches of records for processing. The timer cycles through the records that need to be processed, adds them to batches or buckets that can be marked as processing, and then triggers an event that will be consumed by a consumer application. This consumer can use events internally to process the buckets of data until all the required steps have been completed. Then it can mark the buckets that have been fully processed as completed and continue processing the remaining data until completion. The rules of events mentioned previously, such as the 2-minute processing window and the maximum of 100 event execution threads, are still enforced. So in order to successfully implement this approach, your buckets should be limited to 100 or less to avoid exceptions from overloading the event queues. By using the parallel batch processing pattern, you can build a multi-step processing flow that allows for independent life cycles for handling the business logic required. By using a distributed transaction management approach, developers can use events bidirectionally, replying to the triggering application with status updates while continuing to benefit from the asynchronous, multi-threaded approach that is supported by the event management system in Outsystems Developer Cloud. Last but certainly not least, database events can be built to respond to changes and updates in your application data. Let's take a look. In Outsystems, database entities are generated with pre-built create, read, update, and delete actions. To use events to manage application responses to these events, developers can add event triggers in the CRUD actions to send notifications to the event queue. It is important in this scenario that the database transaction must be committed prior to triggering an event in order to avoid situations where a CRUD operation might fail while still triggering that event. This can lead to false or incorrect information being propagated throughout your systems, so it's critical that database commits are completed prior to triggering the event. Of course, exception handling should be implemented in these cases to ensure that any exceptions that may occur during a commit transaction are properly handled. Now that I've finished the overview of how events work in Outsystems Developer Cloud, let's dive into a demonstration of how this can be implemented for a specific use case. The example application I've built is a hypothetical marketing assistant that can help non-technical users generate effective prompts to create images for marketing campaigns or advertisements. Here's the screen for my app called AI Prompt Maker. This app integrates AI capabilities from AWS Bedrock and OpenAI, specifically calling Anthropic Claude version 2 and DALL-E 3 models. As you can see, Claude responds to my request by generating a detailed prompt that I can then pass to DALL-E to generate an image. Now that the app has been deployed, the management team has requested that IT build a logging system to populate a table that shows the prompt requests, the date they were submitted, and the name of the user who submitted it. Let's jump into ODC Studio to see how this can be done using events. Here we are in ODC Studio, and you can see the screen that I built. It's fairly simple, a few text boxes, an image placeholder, and a couple of buttons. I have a client action behind each button, one to generate the image on click and one to generate the text on click. And those client actions call server actions to invoke the various models. So you can see here that this is invoking the get generations server action, which calls the actual invocation of the API. Now I'm going to go to the Events tab in ODC Studio, and I can right-click on the events or on timers to create an event or a timer. Simply create an event by right-clicking and giving a name to your event. And this was going to be called Notify Users. I'm going to add a few input parameters here because I want the event to be able to pass some data to the recipient on the other end. So I'm going to put in parameters for the request type, the request text, and the requested by name, so I can pass the individual who is triggering this event by invoking the image generator tool. To trigger the event, I'm going to go into my server actions, the invoke Claude and invoke get generations server actions, and I'm going to drag a trigger event from the toolbar onto my canvas and into the action flow for this event. So notice that once I do the invoke Claude or the invoke get generations and assign the results to the output parameters, I will trigger this event, also passing those parameters to the event so that the recipient on the logging end will be able to utilize that data. So you can see here that the trigger event action is going to require that I complete the information that it requires. I'm going to select the input parameters for the event so that I can pass them along to the recipient application, which will be our logging application. Now I'm going to go to the other action here, the server action for invoking the image generator. I'm just simply going to put a trigger event here as well. And then I am going to go ahead and complete the parameters, fill them in so that we can pass that data onto the recipient. So again, the prompt type in this case, as you can see, is image. In the get invoke Claude, I used text as the prompt type, then the parameter prompt and requested by name are passed in. Now I'm going to press one-click publish to publish my changes to the application. One-click publish is usually only a few seconds in a simple application like this, and now I can go ahead and create a new application that will serve as the logging application for the management team. So in ODC Studio, I can select a new app. I'm going to use a web app. You can do a tablet app or a phone app. I'm going to go ahead and just call this new application AI prompts request log. And then I can click the Create App button when I'm finished. Okay, now that my app has been generated, the first thing I'm going to do here is not add an event, but I'm going to click Add Public Element. And here you can see that there are some public elements available that I selected as the events category that come from my AI Prompt Maker application. So because I published that event as public, other applications in my environment can subscribe to it by adding this public element. Now, the next thing I'll need to do is once I subscribe to this, I need to create a new server action to act as the event handler that will process the data that comes over when the event is called. As you can see, because I selected the event handler to respond to that event, it correctly created the input parameters needed. And now I'm going to go ahead and create a database entity to manage the requests and store them so that I can see a history of the log. Once I've created my AI request entity, I can begin to add attributes. And the attributes are basically the fields in the table that I've created. So I'm going to use the parameters that I passed in from the event, the request date, the request type, the request text, and the requested by name attributes will be added. One of the benefits of using the Outsystems platform is that when you create an entity, the create, read, update, and delete, or CRUD operations are automatically completed and generated for you. So when I need to call those to update the database, it's easy to call those CRUD operations. Now, I need to generate screens, and the easiest way to do this in Outsystems is to just drag that database entity or that table into a screen on the canvas to scaffold a screen by using the data. And as this is a simple logging application, I don't need to add requests from here, and I don't necessarily want to have a search capability. Of course, I can use these. And as you'll notice on this page, it also generated a pagination capability. So as this list grows, I'll be able to page through the requests. And as you can also see that the table supports sorting out of the box. Very easy to create screens by scaffolding them using database entities. You can see that the fields are bound to the data attributes that I created, and this makes it very easy to create a table to display any type of data I'd like to in a list of this type. So another thing I'll point out is that by using the scaffolding, we got two screens. One is an AI requests screen, which is our list screen, and we also have a detailed screen. If we wanted to build out a detailed screen to look at details and add entities, we could do that. But here you can see that there's a get requests aggregate that was set up by the scaffolding to populate our table. That's where the data comes from. Now I'm going to go and modify and fill in the details for our onNotify users server action. So the first thing I want to do is when I get this notification, I want to go ahead and create an AI request entity in my database. So I drag that CRUD operation over onto the action flow for my onNotify users action. And then I need to complete the source information. So I'm going to use the current date for the request date, and then the input parameters that I received from my event, request text, request type, and requested by name will be passed into this action. Okay, so now before I go ahead and complete this on notify users action, server action, I want to go ahead and put in a script for my screen. What I'd like this application to do is automatically refresh every 10 seconds so that if any data comes through, that someone who's looking at the dashboard will be able to see it immediately without pressing the refresh screen. This isn't necessary, but just showing that you can add scripts to your screen so that things can take place using JavaScript that may impact your users or the way the application works. So I put a little JavaScript to refresh the screen every 10 seconds. And now I'm going to go ahead and one-click publish my application. Another thing I'd like to do for the logging application is just in this particular example, I'm going to make it accessible by everyone rather than having to log into the application. Again, for demo purposes, I just want to be able to open that screen up. But when I go to AI Prompt Maker, I'm going to set it to authenticated users because I want to collect the name of the individual that is using the application as an input parameter to my event and obviously to populate my database. And in order to ensure that this works, I need to go into the ODC portal, which is a unified portal. We no longer have Lifetime and Service Center. We have the ODC portal. I'm going to go ahead and add myself as an AI Prompt Maker user, as an end user role for the development stage here. And I'm going to save that. So you're going to make sure that you add permissions for any users that need to access the applications if they are required to authenticate to use the application. I'll go ahead and publish my applications and we can explore how this works once this is finished. Okay, now that the publish is completed, I'm going to go back to my prompt maker and just hit refresh to update the application. You'll notice that this time it's asking me to log in with my username and password. Previously, it was not requiring a login, and now it is. I'll go ahead and do another request from the AI prompt maker. So I'm going to go ahead and submit my request to the application. And now I'm going to go back to the logging application. And before I publish it, I'm going to change the length of the request text attribute to have 1,000 characters because sometimes those prompts are a lot longer than 50, which is the default size of that attribute. I published that and now I can go to my request list and you can see that screen. It's anonymous. I'm not going to have to log in to this application. And as you can see, because I have the screen refreshing every 10 seconds after I submitted the prompt, the request was sent to the logging application and added to the table. Once I do the image generation aspect of it, you'll notice that the screen once again will refresh after 10 seconds. And you can see that the request type, the username, the date, all of the information that I needed for the log has been added to my new logging application. I hope this information about event-driven architecture and Outsystems Developer Cloud has been helpful. Thank you very much for your time.